Hello everyone, and welcome to the third in this series of webinars on data in decision making in funds management and investment. I'd like to acknowledge the traditional custodians of this land whose cultures and customs have nurtured and continue to nurture this land since the Dream time. In my case, that is the Gadigal people of the Eora Nation. I pay my respects to elders past, present and emerging. So welcome to the final of the three seminars. The format for this talk is for Anthony to talk with his presentation for about 30 to 40 minutes, followed by questions. Please make sure you ask your questions via the Q&A section of this webinar, remembering you can vote for the questions you like to put them at the top of the queue. And I'll be putting as many of these questions as I can to Anthony after the presentation. Today, we're going to hear from Anthony Corr of Redpoint Investment Management. Anthony is also a lecturer in our Master of Applied Finance program and joins us from Sydney. So welcome, Anthony.
Thank you, Lindsay. So the talk my talk today is on resourcing for increased complexity of data. I've been working, I suppose, with data and with systematic investment processes since 1997. So 20-something years of a career in that process. So the company I work for, Redpoint Investment Management, we've actually been in existence in Australia since 2011, so almost 10 years. And we manage systematic investment processes, so quantitative processes, as we say, across both domestic and global equities. So we've been doing that, I suppose, since that time. The range of processes has grown and evolved. And they range from what people might call a smart beta process through to what would be described as a more active process with higher risk and higher tracking error. So moving on to the topic of the presentation, what I'll be, I suppose, focusing on the way I'll be talking about is if you're starting from scratch, if you want to build out a systematic investment process, what do you need in order to make that a success? What do you need in terms of technology, people, and so on? And then I'll also be talking about how I think that will evolve going forward. So these four topics here are really, I suppose, the agenda that I'll be going through. They're the four things that you need at the heart of a systematic investment process. So I'll talk about data and the different options and ways to source data from different vendors and the options there. I'll talk about the type of hardware that you can use, and I suppose that is one area that's really evolved, particularly over the last 5 years. Certainly, when I started, we were using beige boxes like this in the first couple of shops I worked at, but today, I suppose that kind of hardware won't cut it anymore. Talk about the software, just briefly covering off the software, and also spend some time talking about the people and the kind of skill sets you will need for the systematic investment process. I won't talk very much at all about investment insights. I think that was really covered by Slava and by Lawrence in the previous presentation, so I'll be more talking about technology and what's required behind that. But I suppose the first thing to understand or appreciate is that all of these things on this page, including investment insights, they're all interconnected in a very strong way. So if your goal is to be like a high frequency hedge fund, for example, the kind of data, the kind of hardware, the kind of software, and the skill sets, the people that are going to sit behind that are going to be very different to if you're a smart beta shop where you're perhaps building an investment process that turns over once a month or once a quarter, for example. So they're very different kinds of equipment and skills to deliver the investment process to both of those kinds of investment strategies. Now, I think the other thing to appreciate here is whilst maybe the software, perhaps the hardware, and perhaps the data underlying a research process and a production process are very similar, the root elements of that, the actual way that people go about these two tasks is quite different. They have different needs and different requirements. So the way I kind of think of it as a research process is a bit like putting your goods on the ship here. You'll spend a bit of time collating the data, getting it together, and you usually want a whole long time series or a whole lot of breadth in the analysis in order to make a really robust statistical analysis if that's what you're trying to do. And you'll do things like you'll partition the data into different segments, because you'll have a kind of a testing set that you'll be evaluating your signal on, and then testing how that goes in different subsets and in different groups of that data set. You also might be doing things like Monte Carlo or resampling, or those kinds of more sophisticated techniques to get a lot more robustness in that process. So it's a bit like building a ship. You spend time putting it all together. The ship gets sent off from the port. It may take weeks or perhaps even months to get to the destination, and it might go back and forth on that route a couple of times. So that kind of research process is, I suppose, it's really about getting that data and being creative in that research process to make insights. Whereas you compare that to a production process, and what we have here is the subway map for Tokyo, there's actually a lot of activity, a lot more activity compared to in the research process. And there's stuff going on all the time that needs to be monitored and understood. So if we think about, the subway, its goal is to get people from their origin to the destination, very efficiently. And it's the same kind of thing with the data flows through a production process. It's about getting the information from the original source to the users of that production process in an efficient and timely manner. So some of the other key differences between the two, besides efficiency and robustness, is that the production process will have a lot of automation control. It will have, if you will, a real-time visibility into where the state of it is at different points in time, where data is up to its data flow. There'll be a requirement, for example, for audit. So if, for argument's sake, and this does happen, that data that we received yesterday changes today for whatever reason, it could have been an error at some point in that whole process flow. You need to be able to, track that it has changed and have an audit process to review those decisions. So that is included there, whereas in a research process, you never really consider that kind of thing. There'll be a need in a production process to back up. So, if, for example, we've recently had some cyber attacks here in Australia. And if, for whatever reason, your system gets corrupted, you need to be able to roll back to the previous state and then rebuild from there. So backup's very important as part of that live production process, as is disaster recovery if it's not available. And I suppose the other key difference is data history. In a research process, they really want to get as much data and as much history as they can possibly get to try and get a much more statistically rigorous answer to their question. Whereas in a production process, that length of history isn't anywhere near as important. It's really about delivering the latest piece of information to the users of that data. So there's actually a different kind of skill set, a different mindset when you're building out both of those two elements, even though they're both required to build out a systematic investment process. So moving on to people. So I guess there's really two types of people that are required to build out and work with a systematic investment process. And what I've described here is it's a group of people that can determine the rules, the systematic rules that the process should follow, and they'll be able to code that. They'd be more in the research mold, but they don't necessarily have to be. They can, I suppose in both of these skill sets I've described here, that people can move between them, and they often do. And I think if they can, that actually makes for a better work team. So the kinds of job titles, if you will, for all these kind of designers of the systematic process, there'll be things like quant or data scientist, researcher, analyst. I guess the title doesn't really matter. It's the skill set that they're bringing. And the other type of people, when you think about the production process, the Tokyo subway map, you need people who are skilled at optimizing data flow, designing robust investment systems with those notions of audit and visualization of the state of the system. So, if you can think, I think about it this way, is the top group are building the investment IP, the second group are building the systems IP, and both of those are really required to work together to make a successful systematic process. The job titles that the second group might have are things like quant developer or even quant systems engineer, programmer, analyst. I suppose the other point to understand is that domain knowledge is very important. Just taking people with those skill sets and plonking them into developing an investment process probably won't work, because they don't know, they don't have a background knowledge in things like what a corporate action is, or what an index future is, and all those kind of nuances that people with experience in finance understand and have learned. So now moving on to data, I think the first thing to appreciate is not all data is the same, I suppose, and you just can't get data and start working with it. You really have to be systematic about, or very strategic, I suppose, about the universe of interest. Just getting a lot of data that isn't really going to be used, and trying to build a production process around that really means that you're going to have wasted energy. The whole build time, the whole processing time is going to take longer, and you're probably not going to get any value out of that additional data. So narrowing that universe down to the asset classes, or the regions, or the segments of the market that you're really interested in, it's quite an important thing to do. And if you are careful about that, that means the rest of the process will actually work well when you build it out. Now, the other question, aside from universe, is obviously where do you source data? So the first data, or the first type of data I've listed here, is what I've called commoditized data, and this is, I suppose, fairly public information that's available in lots and lots of places. So commoditized data is really going to be the cheapest data that you can source, and there's lots and lots of data vendors that can provide that to you. The next kind of data I've got listed here is semi-commoditized data. Now, if you take, for example, analyst estimates, so this is where a broker or a research house has got analysts that are looking at companies and assessing companies, and they provide estimates of earnings and all sorts of financial information about those companies. So they'll provide that to a range of data vendors, and that's great, and all the data vendors will have the latest pieces of information from all those analysts. But the quality of the history very much depends on whether or not those data vendors were, I suppose, in existence at some point in history. So if we wound back to, say, the year 2000, when there was, a lot of, it was a big shock, I suppose, in the market with the tech bubble, or the subsequent burst of that. Whether or not your data vendor has good quality analyst estimates back that far in time depends on if they had the skills and the systems at that point in time to collect that. Because this kind of data it exists, it's kind of temporal, it only exists when it's being published, and the history of that is generally forgotten or lost. So the same goes for things like capital structure. Was the data vendor around when the company published their capital structure at that point in time? So if you want that kind of information, it really depends. That the data vendors that have that will be, I suppose, have the long history of that, will be a fewer number. And the other one, I suppose, that is maybe not appreciated is the idea of point-in-time timestamping, point-in-time stamping. So company fundamentals, if we were to think about the financials for a company, and they might have a fiscal year end of 30 June, that company will probably release a set of those accounts, a very small set of those accounts, roughly about a month after that fiscal year end has occurred, and they will publish things like their high-level revenue, their earnings, and a few of those high-level items, just to give the market an indication of how they've travelled over the preceding period. And then what will happen is they'll have an audit process and all that kind of stuff, and they'll publish the full set of accounts with a lot of granularity, perhaps 1 or 2 months after that. So it's important not just to receive company fundamentals, but to actually understand when they're available to the marketplace when you're thinking about building an investment system to utilise that information. So just because a company had an earnings of X, you don't know when that was actually known to the market. And if you're looking at a more granular level, like their accounts payable, for example, that was probably only available at a later point that perhaps the earnings was. So incorporating that kind of information into your investment process is A, important, but B, not all data vendors have the history. Other kinds of data, you may or may not need risk forecasters. Lots of data vendors that will provide that information to you, and you may not need index constituents. Now, I suppose the big area that's growing at the moment is alternative data. So I suppose there's different forms, not alternative data is the same. The first form to understand is it can be very raw. So you could have a raw satellite image, you could have shipping information about ship's gone from A to B, companies bought goods that were on that ship or provided goods that were on that ship, that kind of information. So that's very raw information, and you probably need to do a lot of analysis on it to make it into an insight that you want to use in your investment process. Another, I suppose, great example is the first two here, which is news. So there's a number of companies data vendors that will provide you company news in a machine readable format. So you can then take that and determine things like sentiment and so on that you're using your own techniques. Earnings transcript is a similar kind of raw data set where you can get a transcript of an earnings call from a company, that is where management is telling their analysts what their how the company's performed and giving them an update. So that the transcript of that earnings call is available. So the next level up is, I suppose there's a bit of IP in the next level up, and there's a number of data vendors that will score that information. So rather than just giving you the raw news item, they will apply their own natural language processing or other machine learning techniques to score the news item to tell you what the sentiment is. Is it positive, negative? How many companies does it to apply to, and which ones are they? And a couple of interesting ones here on the earnings call. You can get a similar scoring of the earnings call. Was it a positive earnings call? Was it a negative earnings call? But some vendors are going a step further and looking at the voice, how the management responded. Was there stress in the voice? So the actual audio transcript, was there stress in the voice when the analyst was asking questions to the company management? So you've got very raw, and then you've got a next level up, and I think depending on how much work you want to do to incorporate that into an investment process, you may choose to go with the pre-scored information, which is available to many people, not just yourself, but that's an option for you. Another one is what I've called here is vendor proprietary. So if we take airline traffic, for example, there's organisations out there that have what they call a give-get model, where you'll have various airlines, and obviously not many are flying at the moment, but if we roll back 12 months, you've got a lot of airlines around the world who have information on their traffic, their routes, their pricing, their yields, their on-time running, all that kind of information. And in this give-get model, they actually give that to an aggregator who aggregates it together and then gives it back to the airline in an aggregate form, so they can compare their performance against their competitors. So I guess it's a very altruistic venture in that sense, but I guess they're all benefiting because they've all got more informed knowledge about their market positioning. So that vendor proprietary data will also be made available to the likes of fund managers and other organisations, should they be interested in getting that data set that is proprietary only to that vendor, that collects and collates and engages in that give-get model. The next one there is manager proprietary. So we at Redpoint, we collect news ourselves, and we score that for our own investment system, or sorry, investment decisions, I should say. And you heard Slava last week talking about how dimensional they get. They collect their own ESG data for certain ESG metrics that they think are important that they can't otherwise get. So we've got different levels of alternative data in different kind of forms and collated in different ways. And I suppose the point here is that there are literally hundreds and hundreds of different alternative data vendors. Unlike, I suppose, the other data sets I've described up here, is there's actually a lot of breadth in that data set. Alternative data, I should say. So moving on to software, and I won't spend very much time on this page at all. But I suppose you're going to obviously need some software. And if we start over here at data storage, there's a couple of different options. So you can go with, I suppose, a standard relational database, such as MySQL Server, or you can get an open source one like MySQL. And they're often very commonly used because they're relatively cheap, well understood. There's a number of efficiencies there, so you can incorporate that yourself. Usually when organisations start on this process, they'll actually store the data in a native format, be it MATLAB or R files or whatever native format their scientific programming languages store data in. But there's actually a couple of, particularly over the last decade or so, there's actually a number of alternatives to these, I suppose, old school, we'll call it, relational databases. So things like Cassandra and MongoDB. They're very good, particularly at what they call unstructured, which is the alternative data. So storing data that doesn't have the same standardized format. It's usually not necessarily numeric, and they have a strength in storing textual data, news data, that kind of non-standard data sets. And then there's cloud options, and I actually talk about that on the next page when I talk about hardware. Now, under scientific programming languages, I suppose the big one right now, if you talk to people, what's the up and comer, is the language Python. So that is actually both a general purpose programming language as well as scientific programming language. It's really broadened itself out to be in that kind of scientific language bucket. And you need these languages obviously to do statistical analysis, the kind of more numerical calculations, because they have inbuilt in them lots of libraries that make that kind of calculation. Simply you don't have to code it yourself. We actually use MATLAB at Redpoint. We're quite heavy users. We also use Python and SAS, but probably the two main ones are MATLAB and Python. So MATLAB costs you money, but I would say it's worth the price. It's not a lot. It's not very expensive, and you get a lot of benefit for that price. But a lot of firms are going for these open source solutions. So R and Python, they're viable solutions and they're open source. As is Julia, and I think that's an interesting one that's probably we'll see more of in the next 5 to 10 years. It is very, very fast and very efficient, so I think it's suitable to certain kinds of calculations. It came out of MIT probably in the last 5 years. It's kind of a development language that's blossomed into a more commercial product. Now, there's a couple of specialist languages, and you might go down those paths if you're, for example, that high frequency hedge fund that I talked about at the beginning. They may use some of these specialist languages that are really very well suited to those kinds of problems. So let's move on to hardware now. So I've said here there's 2.5 choices in hardware. So you can buy hardware and build out your own investment system. That's a valid option. That's what a lot of firms have historically done because that was the only way you could do it, really. And then the other one I've said here is you can rent it in the cloud is probably where that I'm thinking of under that model. You can actually rent hardware too, but that's more just a leasing option rather than using somebody else's hardware on another site. So renting it in the cloud, and I suppose there's many providers here. The big ones are Amazon Web Services, Azure from Microsoft, and Google is, I think, coming up very strongly in that cloud option as well. Now, I suppose the reason why there's 2.5 choices is they're not mutually exclusive, and I think that is the way that organisations will be evolving to. Is they will buy some hardware and utilise that themselves, but they also rent some where it makes. And there's actually business reasons, business cost reasons why renting it from time to time will actually be a viable option. And I think the other point here is that renting hardware is actually, I suppose, a bit more nuanced. So you can get the hardware alone, and you might get that from Amazon or Azure or whatever. You can also incorporate some software as part of that, and that's probably more in the guise of software as a service. And now some organisations actually, rent you the hardware, the software, and the data. And then the next level down is a hardware, software, data, and investment signals. I've called that alpha as a service. So there's several organisations that will give you kind of raw or processed data, as well as a signal that they've generated, whether that's value or quality or any other kind of investment signal that they've generated using their own intellectual property, and you're permitted to utilise that if you wish. So I've got, I suppose, a bit of a deep dive here on Amazon AWS. And I've gone back to AWS, I suppose, a number of times in the last 5 years or so, just to see what's they've got available. And every time I go there, I can see more and more applications getting added. So they really have some interesting stuff here. They've obviously got blockchain, which is a big thing in that ledger management of transactions. They've got things on robotics and satellites, so actually analysing satellite imagery using their technology. I'm not sure what quantum computing is, or technologies, or I should say. I didn't think a quantum computer in I suppose, commercial setting had been invented yet, but perhaps they've got something in that, guys. I don't know. So you can see here that if you're a systematic investor and you want to build out your own systematic investment process, that there's probably 5 buckets here that may be of interest to you. So you probably need some sort of database to store and run your systems on. You'll obviously need some storage. You'll need some compute servers to calculate your investment process, your investment signal. You'll need to get data in and out, migration and transfer, and you may or may not be interested in this machine learning option that is there. So they've got pretty much what you want out of the box. Now I won't explain every number on this page. I think people who are who I suppose are in the business or understand how these things are structured will be able to interpret the numbers. But what I've done here is just using the public information, and anyone can go onto Amazon Web Services and get this information. You don't even need an account to learn what the costings are. I've effectively quoted up 3 computers here. So one's a database, and that's using their Amazon Aurora database, which is a Postgres-like kind of database. So that is both, if you will, the hardware that the database runs on, as well as database. So this is in that hardware plus software, guys. And also 2 compute servers to run the rest of the investment process on. So you might want those 2 things. Now the specifications here, they're probably a bit generous. I think they're going to be quite efficient, and it does depend on what kind of investment process you're building, but I think the specifications are going to be generous and fast, and I don't think you'll be unhappy with them, but nor are they at the fast end of or the big end of the spectrum. Now if we go across to the costs here on the right, so I think the beauty about these cloud providers, Amazon is a great example of this, is you can choose anything from an hourly rate, and rent it by the hour, and that means spin it up and run it for an hour and shut it down, and you've only paid your in this case $5.60, and it's American dollars. Or you can actually get a machine or a virtualized machine that is dedicated to you on a long-term contract. I've priced here a 1-year term, but you can actually go up to 3 years, and you'll pay up front in this case. And you can have that available to you, and you've paid it up front, and you can use that for the next few years. There's a range of options there, and they've got everything in between. So if you run with this specification here, you've got using their accounting for how long or how many hours they would see people using within a month. You've got $85,000 cost, and that's American dollars there per year, or $56,000 if you're willing to pay for those 2 boxes up front, 3 boxes I should say up front. Now I've also included here some backup and a little bit of redundancy. There's quite a bit of geographic redundancy within Amazon's offerings, but I've also included backup. So you really, using those pricing there, you've got a system, including a database, including software. You've got data that you could start off and run, and it's going to be, I suppose, credible with many other systematic investment processes at other shops that are already running. So when I look at those pricings, I think, well, if I compare that to a build it and buy it and build it option, well, yeah, it's going to be more money buying it from, renting it there from Amazon. But the things that you don't have to do if you go and rent or utilize the Amazon services, you don't have to worry about a whole lot of other things. You don't have to worry about a virtualization layer on your hardware. You don't have to worry about, licensing and configuring that. You don't have to worry about configuring the actual hardware of the system itself. You're going to need an engineer who knows about that kind of thing to do that. The software and licensing is already covered for the stuff that they provide. You don't have to think about backup. You don't have to think about disaster recovery, or not to the same extent. Hardware maintenance, well, that's on Amazon. It's up to them to keep that running. And nor do you have to think about even management of all of those things. So you don't need someone who will necessarily run all that for you. I suppose the person that would run all that for you would, their time spent doing that would be reduced if you went with an AWS option. So when you look at it on a kind of like for like basis, that actual option from Amazon, it is, it's probably more than you could cost that out. If you were to build it yourself, it's probably more than that. But there's a whole lot of overhead that you don't need to think about. And I think the other point here is every time I look at this, and I've done this a number of times in the last 5 or 10 years, the cloud costs keep dropping, and they keep dropping to a point where I think people are really starting who have historically built it themselves are really starting to say, well, maybe this is a genuine option to move stuff into the cloud. It may not be now, but it's probably not too far in the future that it becomes a viable option. Now, the other one is, if I take back a couple of slides, just explain this thinking. So I've covered, if you will, the buy it option, the rented option with some software and hardware. And the last option I'm going to talk about is this alpha as a service, hardware, software, data, and investment signals. So I've called it an all-in-one model, and there's a couple of organisations like this. They're a little bit, I suppose historically they're at the fringes, but these days they're becoming more mainstream. So the one I'm focusing here on is called Quantopian. So if you just take what they say on their website, Quantopian provides you with the tools, data, infrastructure, and educational material to help you develop a high-quality algorithmic trading strategy. So I think if I read between the lines a little bit, they were set up in order to, they call it crowdfunding investment ideas, but they were effectively set up for some hedge fund or hedge funds to identify good traders who might have trading strategies that they could basically bring a person in-house or bring the ideas in-house. But what they've, I suppose, evolved to is they actually give you a lot. They give you quite a lot of information and quite a lot of data for actually free. So if you take what they call the community offering, it's actually free to get on there, and you will get an access to an awful lot of data from FactSet. When I look at that and go, well, FactSet will charge me to use that, but why they're giving it to them for free? Well, that's obviously their marketing strategy. You won't get the latest history, so you can you will only get up to the last, say, 6 months of data. You'll get everything prior to that, I should say. In the last 6 months, the data won't be available, but you can utilize that to test your strategies, to learn about investment management, to learn about building portfolios. Educational materials are really quite extensive, down to portfolio construction. They even got quite a lot there on numerical and statistical techniques. So there's a heap of material on there, and a really good, I suppose, playbox to learn about systematic investing on your own time, I guess. Now, the other thing that they do is you can license your IP, exactly to whom, I'm not sure, but you can, if you generate a trading strategy on their system using their tools and so on, you can license that to other people. Now, I'm not sure if that's anonymous or how the actual licensing model works, but it seems to be, I think that's the way that they're identifying good, I suppose, good analysts is by looking at their IP, licensing it for a period, and if they like it, they'll probably give them a job. Now that is, I suppose, where Quantopian started, but these days it's evolved into what they call Quantopian Enterprise. And what they do is they say they target at-work users. So I think it's somebody that perhaps had access to the community offering, the first one here initially, and then they moved into a work environment and they want to continue utilising the same infrastructure and the same system, so targeting at-work users. You get access to an awful lot of access data, much more than you had under the free offering, which is still quite a lot of data. Also, you can then load your own data and build your own systematic investment process using their infrastructure and their applications and libraries and so on. So, I think this is a model where you can actually get up and running relatively quickly because you don't need to worry about the hardware, the software, all that kind of stuff. It's actually already there. And if you need some further education, it's actually there for free as well. So that is, I think, a really interesting direction that some firms, organisations are taking in this systematic investing realm. So in terms of the future, I think it's fair to say that, well, not just systematic investing, but IT in general has reached a bit of a pivot point, but certainly systematic investing has. There are, a number of really robust compute services and resources that are really readily available in something like a turnkey state. You don't have to do too much to get them up and running and operational. The software that people historically paid a lot of money for is now either very cheap or in some cases free. And that is really, it is quite powerful software and it is quite sophisticated. There is a lot of data already available, fairly cheaply or for free. And that's the kind of commoditized or semi-commoditized data. The alternative data is more expensive because there's a lot more, I suppose, work that goes into collating that. But certainly that commoditized data there's a lot of it available and quite readily available these days. So when I look at those three elements, cheap compute resources, powerful software, lots of data available, I immediately think of this is I suppose, an environment where people will have a go at machine learning. They'll just throw the data into the machine. They will use whatever algorithms are appropriate for the machine. So they think are appropriate and are easy to get up and running in the machine. And I think the thing about machine learning is you can get a model out of that very fast. Now, whether or not it's a good model is another question, but you can certainly get an output in quite a fast way. And I think the belief is that it's without necessarily a lot of statistical or finance knowledge in order to get to that point. So if you look at what Amazon say, they're putting machine learning in the hands of every developer, and that's, I suppose, what a lot of the direction that some of these machine learning toolboxes are going for is just giving you the tools and off you go, and you don't need a lot of background knowledge necessarily. However, I think that investment decisions is really important because we're managing people's money, and in many cases it's for their retirement, it's their life savings for retirement, and it's really important that that's managed well. So you need to understand investments, you need investment insight, and you need to understand risk well. Machine learning is a technique, and it's fine. It's absolutely fine. I think it will evolve and be part of finance going forward and systematic investment processes going forward. But there's a big difference between running a machine learning algorithm to determine if a picture is a dog or a cat versus running people's money on it for their retirement. I think there's a big step up there, and we need to make sure that, I suppose, as an industry, that the right decisions are being made. So investment insight and risk is important. And the second aspect to there is, particularly if you're using a statistical technique like machine learning, is a sound knowledge of statistical inference is important. So you understand what the machine is telling you when it gives you a p-value or a hypothesis test or whatever the other elements are there that are in there. Understand what that actually means in order to make an informed decision about whether or not it's a good model or not. And I think there's a number of instances in history where ignoring or having ignorance of those two facts and or ignoring them for people actually should know better, and that has actually led to fairly bad outcomes. So I think that the future is good in the sense that a lot of the stuff that we use in systematic investment pricing is getting cheaper and better, but we also need to make sure that we're doing the right analysis and going for the right analysis in the right way. So moving back to the agenda, so I think data is evolving and changing, and there's a lot more data. It's becoming cheaper, and there's a lot of alternative data being available. Hardware is becoming very cheap and much easier to use. Software is very cheap in some cases. But I suppose the two constants in here are that investment insight is important, and we still need to make sure that is the overriding thing when we go in building out systematic investment processes. And the other aspect here is the actual skill set required to utilise all of this stuff actually hasn't changed since when I started in 1997. The kind of skill set of having people who can make a production process really sound and robust and develop and enhance investment ideas. That is the same skill set as it is today. So now I'll hand back to Lindsay, who can take over and answer any questions.
Thanks very much, Anthony, and thanks for the presentation. I've learned a lot out of watching all three presentations, and I'm interested in, this is my question, I'm interested in the notes you had about, the types of people involved, your quants and your quant developers and the analysts. Do you think over time that there's going to be a drive for those developers, those quants, to know more about the investment process and what's behind investment rather than just be a specialist in data?
Yes, sorry, that's a good question, Lindsay, and I missed a point there that you just reminded me I was trying to make, and that was at the bottom of that slide, which said that domain knowledge is important, which is why the courses from Macquarie University, or well, all universities, but Macquarie University in particular on finance, Master of Applied Finance and so on, are important to that domain knowledge, which is about finance.
Yeah, I thought that was the case, but I was interested to know whether you see that going forward. I see that you need to have people who understand what's going on as well as what's going on under the hood. So
yes, I agree with that point. Yeah.
We also have a question from Elizabeth Sheedy, which is a great one, which sent me off looking at websites to see what she was talking about. Do you know of any fund managers that look at employee review sites such as Glassdoor? Some people think these are a good source of information for company culture. And related to that, what tools are people using for text analysis? She is using Leximancer, which I had a look at, and is actually a text to analytics converter in her academic research, and I know that some people use IBM Watson to do similar things.
I actually don't know anyone that's using those sites. I think the thing is, when you're working in a fund manager, you don't really know what other people are doing. You might hear bits and pieces, and generally they will keep the most valuable stuff secret, so you don't tend to know. But I have no doubt that there are organisations that use that. We actually used our own, I suppose, our own developed natural language processing system because we were focusing on a few key things in our news analytics. But those ones that Elizabeth has mentioned are quite common and popular.
Yep, fair enough. Thank you for that. I also, it was interesting to see that Macquarie University has a Glassdoor rating and it's 3.9 out of 5. There's another question here. Even though the cloud appears to be getting cheaper, can you comment on the costs involved in running a cloud solution where large global data sets are used and where a large number of simulations and resources may be required? Is that really cost effective yet?
I would say if you're doing a lot of simulations, if you're going to spec up a 60 core machine with if you need 300 gig of RAM or whatever, that's going to be very expensive in the cloud. So it probably is not the place to be yet. But I suppose where I would see that going is that will continue to become cheaper to the point where when you consider the cost of the extra pieces, it becomes a lot closer.
I would reiterate that by just telling you about the experience I had working in a financial markets business where, you know, they wanted to do XVA calculations but never had enough boxes. And the only way you could get the power you needed to do those sort of calculations was to use someone like an AWS, a cloud provider, to do that. Otherwise, you're just buying lots of boxes for the sake of running a couple of calculations at a time. And it made more sense to actually go and outsource it. I guess one of the things that comes up a lot with cloud services is the security, and you know, AWS do a lot on security. I know that, you know, all the banks where they use AWS have, you know, password encryption at both ends. What sort of things are you seeing in that security side? Is it an area that people were really concerned about?
I think, yeah, yes and no. Yes, well, yes is the answer. It's been like, if we take the example of the simulation that the person asked before, that that's probably not that. While security is important and it's confidential, the risk of that getting out into the to the mainstream is not that large. And I think that in terms of security, the biggest risk there is reputational risk of private information of clients, of, you know, people getting out into the public domain. That's the biggest risk that most organisations would focus on. If you've got, you know, a quantitative system that you've developed that pretty much you and people in your organisation understand, that I would say the risk of that, as long as you've got sensible security around that, the risk of that being exposed is actually pretty low.
Okay. Here's an interesting one. What strategy would you use in this ultra-low interest rate environment where financial asset prices are inflated by the overprinting of currencies? I guess we're asking, you know, are there other things, other signals that we should be looking at?
Well, I suppose, yeah, that's my question too, to be honest. Yeah, it is a very, very unusual market environment. And we've seen, I suppose, traditional signals such as valuation, one I'm thinking of, really, really struggling much more than they have in any point in the past. So I think a lot of organisations, including our own, are really thinking about, you know, how we should operate in, you know, this new economic environment that we're going to probably see for the next foreseeable future.
Yeah, no, it certainly is going to be around for a while. Another question here. The first talk, Lawrence's talk, discussed the idea that the key difference between, I think it might be facts in finance versus analysis, regarding pictures of cats, for example, is that financial data is more transient. How do you think about this when it comes back to testing your own ideas?
I actually interpreted Lawrence's comment, I suppose, slightly differently, in that we create financial data. It's not a natural thing that exists. Obviously, a cat exists, a dog exists. Human interaction is the thing that creates financial data, which means that we change financial data by their very interaction into it. So I think the way that you know, we as a, I suppose, organisation deal with it, and this I think is true of the finance industry in general, is understanding the fundamental investment rationale, the financial rationale, why people make decisions, and how they determine what to invest in or what they find attractive. You think of you know, behavioural finance, you know, those kinds of aspects about why they lend themselves to particular types of securities versus others, is the way that we deal with that. But there is no crystal ball that anyone can look at to understand that well enough, I think.
No, I would agree there. And thank you. Thanks for all of those questions. If there are any more questions, please pop them up now, the last chance you have. Otherwise, I would just go back and reflect on the three presentations we have, where Lawrence was very much talking about, you know, what are the things you need to consider, what sorts of things to get into using data in your investment process. Slava gave you some very concrete examples about how you can use sustainability data in investment and factor investing. And then Anthony here has just given us a lot of information on the things that you need to consider when you're going to, I guess, industrialize this process in an investment fund or investment management. So I think over the 3 sessions, I hope everyone has learnt a lot over these. And once again, thank you, Anthony. Thank you to Slava and Lawrence as well for their contributions. These recordings will, of course, be made available after the event. And we'll look to having more webinars in the future, starting very shortly. We'll hopefully have one next month that we can invite everyone to. So once again, thanks everyone for your time today. Thanks for coming on. Thanks, Anthony. And thanks, Kate and Macquarie, for putting this on. Thank you.
Thank you.